Okay, so we'll start with dimensional modeling today. Okay, I'll just explain you what is a dimensional modeling. Then we'll proceed with what is a logical and physical design. We'll go with dimension tables. What are different types of dimension tables? Then different types of fact tables. Okay. So after different types of dimensions and facts, we have different type of schemas. Okay. So we'll just see it impacts on designing our reporting metadata. Okay. So while starting with dimensional modeling, we'll just look into the concepts of ER model, entity relationship model, which is used in our OLTP systems, okay, to join the tables. Then we'll slowly move on to dimensions and fact tables. We will see what is a dimension table, what is a fact, and the different type of schemas. Okay. Now, first, the first point is like what is a data model. Okay, so without a data model, as a developer, we cannot make a join between two tables because we are working on relational overlap systems, right? So everything is driven through a join and a primary key and foreign key concept, right? So your data model is nothing but conceptual representation of data structures called tables required for database and is very powerful in expressing and communicating the business requirements. Okay. Now, data model helps functional and technical team in designing the database. Okay, and there are different modeling tools as Erwin, Oracle Designer, and Power Designer like this. And you have two phases of data modeling, which is called a logical modeling, and one more is called a physical modeling. Okay, so we will just have an idea what exactly is a logical modeling, and then we'll slowly move on to physical modeling. Okay, so logical model is nothing but a blueprint of your tables in business terminology. There won't be any physical existence. You analyze your business, you think that few entities are required, you design them, you make a particular key as primary key, you design a particular key as foreign key. You are not physically creating it in the database, you are just designing it. This is just a logical design. There won't be any physical existence in the database. And once you are doing your logical modeling, you can put it on top of any database. Okay, so logical modeling acts as a blueprint. So before construction of a house, what you do? You go take a plan with engineer, right? The same thing your logical modeling does. It's like a blueprint or like a plan. Okay, I should have table called employees, I should have a table called student, okay, and so on, right? And I should have all these attributes. I should make employee ID as a primary key, I should make departments as a foreign key, like this, right? So you are just using the business names for entities and attributes. See, it is just on high level, on a business terminology. Your logical modeling is designed. Okay. Next. So what is a physical model? Physical model is then you decide some database name. Suppose say Oracle database or Microsoft SQL server or Teradata, anything, that's up to you. You decide a particular database, you take the logical model, start writing the scripts. Suppose say for a particular table called employees, what you do? Create table employees with all the column names like employee ID, employee number, hire date, job ID, department ID, everything. You write it and you execute that in the database, you create the table. So that is called a physical model. And what are all the things we do here? We have data type for each column. We have specific length described. We have constraints for each columns. We have constraints at table level as well as column level. So all the concepts that we studied are being implemented in your physical models. Whereas your logical model just says this should be my primary key, this should be my foreign key. And that does not say anything about your data types, like this should be varchar, this should be number and everything. This will just say I need employee ID, that's it. Your logical model just says that you need employee ID. And when you go for implementation, you give that a specific length as well as data type as well as any constraint, everything. Okay, so okay. Now,
hear anything? Anyone?
hello.
Yeah, I can hear you.
Okay.
Hi.
Sure. Hi. Okay. Now, use more defined and less generic specific names for tables and columns. Okay. So you don't use any business names here. You use more database related names and all the terminologies with respect to a particular database. Okay. Includes primary keys and indexes for data access. So all the indices, triggers, synonyms, sequence generators, everything you create, you properly design it as a data warehouse and you use the tables for your analysis. Okay. So there is a diagram which can easily differentiate your logical modeling with your physical modeling. So your logical model contains, suppose say, a time dimension. This will have date description. You can observe that it does not have any data type. We are only making a note that I should have all these columns, and there is something called sales which has all the foreign keys, and each and every dimension table has a primary key. But here in the physical model you can see that each table have columns with specified data type, okay, as well as specific length. Okay, so you can just differentiate between your logical model as well as your physical model. Physical model, once you create it, it's with respect to a database. But logical model, you can use it on any database, right? So you can create the tables using your scripts in different types of databases. But once your physical model is created, it is specific to a particular database. Okay. Now, okay, go ahead.
Chanikya, sorry for interrupting. Can you just give me an overview of what you have gone till now? Because
okay. No. We just started. With what is logical modeling and what is physical modeling. That's it.
Okay.
Okay, nothing else. So we are just differentiating the logical model with physical model. Then slowly we will proceed with the dimensional models, fact tables, dimension tables, and different schemas. Okay.
So Chanakya, actually, I did not see any specific logics in the logical model. Why do they call it a logical model? Usually, physical model has more logics that varchar and how much is the length and everything. But logical model does not have any specifics, and even though it can be used for different data types.
See, we should not get carried away with name. Logical modeling. Logical modeling is just as a developer, as just an analyst. What we do, we just first think, visualize of a table. We feel that we should have a particular table with 10 columns. Okay. So this is just while we are analyzing something, so we just think that I need a so and so table with so many number of columns, and this one of the key column will act as a primary key and the other will be foreign key, like this. So even while creating aggregate tables or while creating any table for ourselves, we'll don't start with writing script directly. We'll start that. Okay, after multiple discussions with all the analysts or all the business people, what we do, we think that a particular table is mandatory for us. It's required for our analysis. In that case, first we will make a design document. So what happens, we'll feel that okay, I want something called products extension table, or otherwise we will say something, I want something called sales aggregate table, for which has 2-year aggregated data at month level. Okay. See, here I am not speaking anything about my columns, what all the columns it will have, what is the data type, what are the primary keys, what are foreign keys, how it is going to impact, how I have to schedule this and everything. The only thing now I am in at this point I want is a particular table with certain number of columns.
Okay.
Right? And what are all the columns I want? Slowly I will note it down. That's it. No, even there I am not giving any data type or specific constraint on that. Okay. So your logical model is purely just for creating a exact copy of physical table, and you will just have an idea how your database looks. That's it. Okay. So before doing
Kind
so,
of a blueprint on which we will make the physical table.
yes, it's like a blueprint, exactly. So referring that, you will make minor changes again, like you see your logical modeling may, your physical modeling may slightly differentiate with your logical modeling. Okay, it's not like it should be in sync. So 1 or 2 columns again when you feel that it's required for you, right? So while designing your data warehouse, you might have started with 100 columns in a table. So slowly again you won't go for a logical model, right? In the future when you keep adding some more columns to a particular table, you will just directly add it. Again you won't refer any logical model that time, right? See, you might have overseen few issues. You might not have forethought or foreseen those issues will occur, and you might be missing few columns in your logical model as well, right? So in future, if you feel that a particular column or a particular attribute is required, you bring it again and you make a changes to your warehouse tables or your custom tables. Okay, that's still fine. But before starting, if you don't have any tables, suppose you have 0 tables in your warehouse, you want to start from the beginning. See, and just keep in mind, this is a theory. No one will start with starting from the first table. You cannot see such data warehouse nowadays. Okay, mostly it will be BI apps implementation or any data warehouse which has come up with all the tables that are required for a particular domain. When I say domain, it may be consumer goods, healthcare, banking, finance, anything, right? When I say particular domain, all the relevant tables that are required for analysis. So if I say banking, mostly all banks have the same type of transactional data, and even the analysis what they do mostly remains the same. It is not going to change much. Okay, maybe a minor change with each bank, but most of the tables will be common. So when I say logical model, in the initial days when we were designing data warehouses, you can have the blueprints, okay, of each table, everything, and then we were doing this physical model. Okay, now you have all the ready-made tables and everything readily available, right? Okay. So now we will just see the difference between logical model and a physical model. Okay, you can see a logical model represents business information and define business rules, whereas your physical modeling represents physical implementation of the model in a database. Okay, this is defined at entity level. This is called a table because we create the entity. We define this entity in your database. And here we call them attributes. Here we call it as a column. We have primary key and foreign keys. We have primary key constraints. Okay.